Hello students. So this will be the second video of chapter 3. So in the previous video we have discussed about force, what is force, okay, and effects of force. So today we will discuss about a different type of force. I think we have discussed the frictional force, okay. So first type of force has been discussed. Now today we will discuss the second type of force, that is our normal reaction, okay. So what is normal reaction? So suppose this is the ground or anything, this is the surface where we have put one wooden block. Suppose one wooden block is put over the surface. Now this obviously this wooden block will be in rest. Now this wooden block will be have a weight also. So this wooden block will exert a force that will be equals to its weight, and this weight will act downward. The weight of the wooden block will act as a force. That force will act downward. Okay, but the body does not move. That means that why the body is not moving? Because the surface at which it is held, the surface also exerts an equal and opposite force over the body to the surface. The surface, as the body is applying a force downward, that means the surface is also applying a force in opposite direction. That's why the body is not moving. Okay, that force that the surface is applying over the body, that is known as our normal force, and that force will be opposite to the direction of weight of the block. So this will be our weight of block, and this will be the force exerted by the surface over the block. Okay, so this is known as our normal reaction force. I think it's clear. Okay, so that's why the block is at rest. Why the block is at rest? Because the surface exerts a equal and opposite force on the block. Okay, fine. Next we have our third component, that is tension force. Tension force as applied through a string. Okay, so suppose we have a rigid support, you can connect that ceiling. So from this rigid support, suppose one rope is there, and in the rope we have applied some weight. Okay, so obviously the weight of the body will act downward. This will be our weight of body. So what we have done, so when a body is suspended through a rigid support by a string, the weight of the body pulls the string. This your, we can say, the body, this body will pull the string downward. Okay, whereas the string pulls the body upward by the force which balances the weight of the body. That's why the body keep in rest. That means the body is exerting a force equals to its weight in the downward direction, and the body is not moving. Why the body is not moving? Because the string is again applying the same amount of force that the body was applying, but the direction of that will be in different direction. Okay, so the figure, this figure, you can see that this shows two equal and opposite forces. Which equal and opposite forces? One is the downward force, which is due to the weight of the body, and one is the upward force, which is acting by the we can say the string, that the string is pulling the body upward. Okay, so this is the tension in the string. Tension in the string. Okay, so if tension breaks suddenly or slightly above the body, then it is seen that the string moves slightly upward with a jerk. You can see that. Okay, so if you just tie something, stone or rope, and you just what we can say that if it suddenly breaks, okay, then sometime the body just move little bit upward and again then come at rest. Certain jerk is there. Okay, so this force which is pulling the stone or any object upward, that creates a, that force is the tension in the string. Clear? Similarly, we have the fourth one. The fourth is the force exerted during collision. Okay, force exerted during collision. So what is it? So suppose this is a body, okay. So when two bodies move towards each other, suppose this body is moving and we have another body, these are the two bodies, they are moving towards each other, they will collide, obviously they will collide. So this will collide after some time, okay. And what they will do after colliding, they will push each other. The first body will push the B and second body B will push A. So in this way equal and opposite forces act on each other, okay. So this is, suppose this is the center of the body A and this is the center of B. So that means here a force will be applied by B on A. FAB means force on A due to B. So this will be in this direction, okay. Similarly the force the body A will again push the body B. So this will be the in this direction. This is the force on B due to A. So in this way equal and opposite force act on each other, and these two forces are known as force of action and force of reaction. This force is known as the force after collision, that the two body will push each other, that is known as our force of action and force of reaction, okay. So after collision, this is during collision, okay. This is the figure during collision. So after collision what we will do? So as the body B has pushed A towards the right, so this will, the body will of A will move in this direction, whereas body B will move in this direction. So this is the two direction after collision. So after collision A will push B, so that's why B will go towards the right left, and similarly B pushes A after during the collision, so A will move towards the left side. Clear? So in the two figure, the two bodies move towards each other after they collide, and during collision B exerts a force AB on A, then this force is known as force of action, okay. So this FAB, this is the force on A due to B, and this force is known as our force of action, okay. And instantly and at the same time the body A exerts a force equal and opposite to the force of FB on the body, and due to this equal and opposite force the two bodies move apart after collision. Clear? So what will be the definition of force exerted during collision? So all forces which act on a body directly or indirectly through a connector are known as contact force, okay. So if you see the definition of contact force, what is it? All forces which act on body directly acting, or maybe it may be indirectly, acts on body directly or indirectly through a connector are known as or are called contact force. Clear? And what will be the non-contact force? So in physics we came across forces which do not make contact and act through space, okay. Without contacting they apply force, fine. So these type of forces are known as non-contact force. So if you see the definition of non-contact force, non-contact force. So in the contact force we need some connector through which the force will transmit, okay. But in non-contact force, without touching or without in contact we can exert force, okay. So we can say that forces which do not make contact and this force act through not any connector but they act through space, okay, and act through space is known as non-contact force, such that your gravity, I think everyone has heard about gravity. If you throw anything in the space, that comes downward. Why that comes downward? Because the force of gravity is acting on every object, that's why they is coming downward. Okay, so is the gravity is in contact? No, that is not in contact. The force exerting is without contact, and or we can say that the force is through the space. Okay, so this ability of a force is due to the body creating a sphere of influence around itself, which we call force field. Okay, so what is gravity? We can say that gravity, what is gravity? It is a we can say it is an invisible force. Invisible force, okay, with which a body is attracted or pulled towards the earth. Any body is pulled or attracted towards earth. So it is an invisible force with which a body is either attracted or pulled towards the earth. Okay, and there is nothing attached to the body, nothing is attached to the body, it is the space which is attached, we can say. Okay, so this type is the these are the example of our non-contact force. Again, I think in your when you are small, you have played with a magnet. Suppose here one magnet is there, here another magnet is there. So when you pushes the magnet A to the end of the B, there is some gap and the magnet moves. As the magnet A is moved in the direction of B, B also moves, and in between A and B there is some gap. Why this is done? So A is not connected to B, but then also the magnet B moves. So these are the, we can say these are A is also exerting some force, but A is in not contact with B, and this magnetic force is also an example of non-contact force. So we can say our gravitational force, some examples of non-contact force. Okay, so we can say example of non-contact force. So first we have seen the gravitational force. So gravitational force is a non-contact force. Then again I have given the example of magnet, that force is the magnetic force. So magnetic force is also our non-contact force. Then electrical force, with the electricity, the electrons move. Okay, so nothing pushes them, it is due to the potential, so that's why they are moving. That means they are also having some force. Okay, so that is our electrical force. So what electrical force? We can say if there are two charges, one positive and another also say positive, obviously we know that the like charges repel. So without come in contact, they will repel each other. Okay, they will repel each other, either it is positive or it is negative, they will repel each other. But if it is positive and if another one is negative, and we know that opposite charges attract each other. Okay, so without come in contact, they are either attracting or they are repelling, that is push or pull, that is they are creating force. So these are also a example of non-contact force, that is electrical force. Okay, so electrical force is also an example of non-contact force. So we can give the basic definition of non-contact force also. You can see the definition of non-contact force in page number 64. What is it? A force which acts on a body without any direct contact. A force acting on a body without any direct contact or without any direct connector is known as our non-contact force. So you just properly write the definition of non-contact force. So you can get it from page number 64. Okay, now we need to know some general properties of non-contact force. Okay, so let us see general properties of non-contact force. Okay, so what we know, for applying force we need some medium. Okay, so they do not, okay, but in contact force they need some connector. Okay, so in non-contact force, force is exerted on the body but without coming in direct contact. So that means what are the properties of non-contact force? That is, the non-contact forces do not need a material medium to act on a body. Okay, so non-contact force, or we can say they do not need a material medium to act on a body. So space acts that. And the second one is that they are generally attractive in nature. However, two similar electrical charge bodies or similar poles of magnet repel each other. Mainly they are attractive in nature, but if in case of our electric or magnetic force, like charge repels and two like poles also repels. Okay, clear, I think. So after the point number 2, you just write the point number 2 from the book, page number 64, you will get this. So after that, a force can bring about following effects as illustrated by the examples below. So using that force, what we can do? Using the force to set a stationary body into motion. Suppose a body is in rest. Okay. So using that force, we can change the state of rest into its motion. How? By applying a force. If we apply a force on a rest body, obviously that body will move. That means after application of the force, we can change the state of rest into motion. Okay, how we can do this? You can see some examples, A, B, C, D. C examples are there. Suppose one golf ball is there. So obviously a player will by hitting this ball, that he or she can make this ball in motion. Okay, so he is transferring his force through his hand by that we can say that suitable stick, okay, or golf stick. And similarly, the railway engine can move a stationary train by applying a force of push or pull. Initially the train is in rest, so after rotating the engine, that engine can either push or pull. Okay, that means initially the train was in rest, so after applying a force by the engine, the train start moving. That means the state of rest converted to state of motion by applying the force. Similarly, a magnet, suppose here one magnet is there and one iron nail is there. So obviously if we bring the iron nail much sufficiently closer to this magnet, then this magnet will attract this iron nail towards itself. Okay, so that means iron was in rest. So if we have bought a magnet near it, obviously the state of rest will change into state of motion. Okay, similarly with the help of force, we can change the state of motion into the state of rest. By suppose how we can do this? Suppose a car is moving in this direction, so if we apply a brake, obviously the motion will come into rest, or the moving car will be stopped. Okay, similarly suppose one football is there. So if we hit the football on the ground, so after some time, due to the force of friction, the ball will stop. It will not continue in motion. After some time, it will in rest. Why it is in rest? Because a frictional force is applying. And what is frictional force? This is the force which opposes the motion, or it resists the motion. Okay, similarly what we can do? Using the force, we can change the direction. Okay, suppose some body is moving in this direction, so if we apply a force here, so obviously this ball will go in this direction. So with the help of force, we can change the direction of the moving body, or we can change the speed of the moving body. How? Suppose a car is moving, so if we change the direction of the steering wheel, that force we are applying the force, and that force will transmit through steering wheel to the wheels. Okay, and it can change the direction. Okay, and the last one, to bring about change in dimension. So suppose you can say rubber. So if we apply a compressive force, obviously the length of the rubber will decrease, and if we stretch it, the length of this rubber will increase. So that means using a force, we can set a stationary body into motion, we can stop the moving bodies, we can change the direction and speed of a moving body, also we can change the dimension of a body by applying a stretched force or compressive force. Clear? So in the next video we will try to discuss the Newton first law of motion and inertia. Okay, so till then you practice all these things which we have discussed today, and if you find any difficulty then contact me. Okay, thank you.